This is just a quick video to prepare for the quiz that is going to be on November, what is the date? November 21st, I think, Thursday. So I think it's covering, if I remember correctly, we're going to do solving one system of equations. We're going to do some power rules, some exponent rules. So the product rule, the quotient rule, and the power rule. I'm going to try to do a real quick problem or two on interpreting solutions. So basically, that's where you are trying to figure out, is the ordered pair a solution to the system of inequalities or not? All right, so I'm just going to start with some exponent rules first. So if we have x raised to the third, and then times, this is the product rule because I'm doing multiplication, and then x raised to the fifth. We keep the same base, so the answer is x, and then we just add the exponents. So x raised to the 3 plus 5 equals x to the 8. All right, so that's pretty basic, easy one to start out with. Again, the product rule says if you're multiplying two terms with the same base, x is the base, the big number, all you do is you add the exponent. So we added 3 plus 5 right here, and that gave us 8. All right, next problem. Let's do one that's a little trickier. So if we have negative 11, we'll say it really doesn't matter what the base number is as long as it's the same base. And if we have the number 3, and then over here we say times, again, negative 11 is our base, so the same number, and this time we say raised to the x power, then we say that equals negative 11 raised to the 8th power. So based on our rule, we know that if we have the same base everywhere, negative 11, negative 11, negative 11, these exponents have to add up to be 8. So the equation, and this is what you have to do on the test, on the quiz, you have two different questions. One is, what is the equation? So the equation is simply, I need to say, well, I add the exponents, so 3 plus x, and that should equal 8. Now I just do the math, I solve. So in order to solve this, I would say subtract 3 here, subtract 3 here. Those then cancel out. I get x equals 5. And clearly we can tell that x was equal to 5 anyway, just by looking at the equation. So that's my solution. Okay. I'm going to erase those and just start over. So that's the product rule. Real quick, I'm going to jump into the quotient rule, do an easy one first. X raised to the 7th divided by x raised to the 3rd. Again, this is the quotient rule because we're doing division. This says that we subtract the exponents, so x raised to the 7 subtract 3, which would give me x to the 4th. All right. A little trickier one, it's more like what you'll see on the test. If we have, it doesn't really matter what the base is, so I'm going to use y in this situation, and I'm going to say y raised to the 2nd power divided by y raised to the x power equals y raised to the 5th power, we'll say. The quotient rule says if I take this number, subtract this number, it should equal that number. So you have to show the equation. So it would be 2 subtract x equals 5. We're simply working with the exponents. We don't need to do anything with the base because the base is the same for each term. So all we're really having to work with is just the exponents because we're solving for exponents in these problems. So the answer would be, this is a little trickier. I would say, okay, well, I need to get x by itself. So as usual, I subtract 2, and that cancels out. that means that I need to subtract 2 over there, which gives me 3. Negative x equals 3. Don't forget about the negative sign that we had. So if negative x equals 3, I need to get rid of that negative sign. I want to get x equals something, not negative x equals something. So in order to get rid of that, division is our last step as usual. So I divide by -1, because technically there's a 1 there. I divide by -1 there, I divide by -1 there. So all that goes away, and I'm going to get x equals -3. So the exponent on the y, the denominator, would be -3. X would be -3. Next problem. Power rule. Power rule simply states if we have a term x raised to some power, and then that entire term is raised also to a power raised to another exponent, all we do is we say x is raised to the 2 times 3. We multiply these two exponents. So we just multiply those two exponents together. And we're going to do that for every term that's inside the parentheses. So for example, if we had a different term, we'll say 3y to the second, and all of that was raised to the 4th power. The first thing you need to notice anytime you're working with exponents is there is always a 1 on every number, a 1 exponent. Right? So if you have a base with no exponent, there actually is an exponent there of 1. So every base has an exponent on it, even if they're not showing it. Well, if we know that that's the exponent, then now we just say, okay, well, I need to take this 4, the 4 right here, and I need to multiply that times every exponent in the problem. So I would just say, okay, well, then I have 3 raised to the 1 times 4, and then that's going to be times y raised to the 2 times 4. And that's simply going to equal 3 raised to the 4th times y raised to the 8th. Make sure you don't add the exponents. Right? So that's a pretty common mistake that I see people adding exponents together since we do that in the product rule. But again, this is not the product rule. This is the power rule. I'm not going to go into a long explanation of how it works, but maybe I will. Just really quickly. If we converted this x squared raised to the 3rd power, that's the same thing as x squared times x squared times x squared. That's what getting something to the power means. So we have x squared times itself 3 times. Well, if we just, now we have the product rule, and it says if we have the same base, the same big number in an expression, and we're multiplying them together, we can just add all of the exponents. So that would actually give us x raised to the 6th power, which is the same exact thing we get here when we multiply those two together. So going back to the original problem, you can see why the power rule works. Next problem. So what else is on there? I'm going to just do a very generic version of this problem. I'm not going to even go to the graph. So if we have a coordinate plane, and so somewhere around here we have 1, 2, 3, 4, and we have -1, -2, -3, -4, and then 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, something like that. If we have 2 lines graphed, so we have 1 line there, we'll say, we have 1 line there, we'll say, one of the sections of this graph is going to be shaded. That shaded region, so we'll use, let's use blue. So that shaded region is our solution region. So whatever section of a graph that is shaded, if there's only one section shaded, if there's multiple sections shaded, then you got to figure out which one is the correct solution region. I'm just telling you right now in the quiz, there's only one section shaded, so it's your solution region. What that means is every point in that region is a solution. graph all the way across. Not that we really need it. So, again, these numbers, this is the origin right here, 0, 0. So I'm just going to simply give you a few points and show you how you do this. So if we had a point that is 3, 2. Let's make that 3, 1, just so it's easy to tell since I didn't use graph paper. So let's do 3, 1. If this is a solution, then it should be in the shaded region. So each line, the red line and the blue line, represent an equation. Actually, an inequality, I'm sorry, or we wouldn't be shading. So each line represents an inequality. What we want to know is, does this point satisfy the requirements, or basically make each inequality true? If it makes both of them true, then it's a solution. Well, since we don't have the equation, the simple way to tell is just, is this point in the shaded region? So let's see. So 3, 1 means I run first, then I fly. So I'm going to go left and right. That's what Superman does. Runs first, then flies. So I'm going to go left and right first. Well, I have a positive 3, so I'm going to go to the right 3. So 1, 2, 3, and then up 1. So I go left and right first, then right 1. So that is my particular point right there. Well, that point is in the solution region. So yes, that is a solution. So let's do another one. I'll now say, what about, we'll say 2 and 3. And I will say 2 and 3. Again, I run left and right first before I fly. So I go right. So if I start at 0, 0, which is the little blue dot in the middle, I go right 2 to get to the x value of 2, and then I go up 3. So again, it's not a perfect graph, but let's say it's right there. Well, that is just outside the region. So you have to be kind of careful on some of these, but that is just outside the region, that dot that I just made, just above the red line. So if it's outside the region, whoops, then that cannot be a solution. So we would scratch that one out. No, not a solution. You don't really need to scratch it out on that quiz. Next one. Let's say -4, 2. So again, I run left and right first, so I would go to the left this time. If you notice, there's actually no negative x value that is going to be in the solution set. My solution set is all positive x's. It looks like it starts at about 1/2 x maybe, so somewhere right in here is where it starts, and then it goes all the way to the right. There's no solution set in this area. There's no shading in that area. So that means there really can't be a negative value of x that's going to work, but just to make sure, let's plot it. So -4, 2 means I go left 4 from the blue dot in the middle. I always start at the origin. So left 4, 1, 2, 3, 4, and then up 2 puts my dot somewhere there. That was an ugly dot. Let's get rid of that. So somewhere up around there. Clearly that is not in the solution region, so I'll scratch that out. And then last but not least, we'll just show you one more that's in there, 5, 1. So I run left and right first, then I go up or down. Actually, let's make it -1. So I go right 5, 1, 2, 3, 4, 5. So I'm all the way out at the far end dot. I'm sorry, the far end dash. I put a dot at the -1. I go down 1 because it's negative. And clearly that dot is in the solution region, the shaded region. So therefore, yes, that is also a solution. So that's what you're going to have to do on the test. Basically, if you know how to plot points, you should get that one right. Any point that's in the solution region. So now let's erase that. I'll give you another example. I'm not even going to solve this one all the way out. Maybe I will. So if I have two equations, y is less than, we'll say 6x, oops, no, less x, 6x, and then we'll say we have 2x plus 5y is greater than 10. So what I need to do, and let's say I had a point and I said, well, is the point, make sure I have one that's in there, is the point 1 comma 4. I'm only going to do one of these, but it works the same way. Is this point 1 comma 4? So this point right here, is that ordered pair? Is that a solution to this system of equations? Again, a system means more than one equation. So is it a system? I could graph both of these lines and, shade them. And if I shade everything correctly and graph them correctly, then I would simply I would plot this point 1 comma 4 and see if it's in the shaded region. And if it's in the shaded region, the region that's shaded twice, it overlaps. If it is, then it's a solution. That's a lot of work to do for just one point. And if you had 6 or 7 points, it might be worth it to do that. It all depends on how fast you graph and if you're comfortable with graphing. I'm going to show you the other way to do it because I don't know that most of you are going to want to graph. If you do, you can certainly do that. So what I'm going to do is I'm going to take this point. This point is a combination of x and y values. So that's x, that's y. Right? So what I need to do is I just need to plug in these x and y values and see if they fit. Actually, let me zoom in a little bit. Go to 1.5. So I just need to plug in these x and y values and see if they make the solution true. And if it makes both equations true, and again, it has to be both equations, not just one equation, it makes both equations true, then I'm going to go ahead and say, yes, it is a solution. Oh, I didn't mean to do that. Let's redo it. All right. I was trying to get rid of the red circles and everything, but again, the ordered pair in red is the point we're testing. And then the two equations are the y is less than 6x and the 2x plus 5y is greater than 2. So all I'm going to do is just, for the first equation, it's pretty simple. I'm going to replace the y with the 4. Oops. I'm going to replace the y with 4 and then then the x with 1. So y becomes 4, and then I just keep the less than, and then 6 times 1. So 4 is less than 6. Well, 4 is not less than 6. I'm sorry, 4 is less than 6. Excuse me. So you have to make sure, be very clear what you're doing. So 4 is less than 6. So that is a check. That is a yes. So put a little check mark by that one. So that means I keep going. If that would have been no, then I would be done. I would already know that 1 comma 4 is not a solution. Now, my next step is I need to plug in 1 comma 4 again, but this time I'm going to plug it in down here into this equation. So 2 stays in there. I don't do anything with that. My x value becomes 1. Plus stays there. And then 5 times 4. I'm just plugging in the y value of 4, just like I did before right there. And then is that greater than 10? Well, 2 plus 20 greater than 10. 22 greater than 10. Yes, absolutely. 22 is greater than 10. So I have 2 check marks. I have a check mark here for the first one. I have a check mark there for the second one. That means, yes, that is a solution to that system of equations. It solved both equations or made both equations true, so yes, it is a solution. That's another thing you're going to have to do on the test. The last thing, I'll do one. I think we probably did this one in class, but I'll do it again. So we did something like x plus y equals 3. This one's probably a little easier than what's on the test. I'll just let you know. And then we had a second equation. And in the second equation, we did something like 5x subtract, I don't know, we'll say 2y. 5x subtract 2y. And that gives us 8. We'll say. So when it's all, man, I do that a lot. I don't understand. That's y, not an x. So we said whenever you see two equations and they're all lined up nice and neat, you've got x values lined up, y values lined up, numbers lined up, even equal signs lined up, that's your hint that you're going to use elimination, or you're going to solve this system algebraically. Basically, that just means you're going to add them vertically. The goal of adding them vertically is to get something to drop out. Like you want one of the variables to cancel out. If I add them vertically right now, though, nothing cancels out. I would still have a y. I would actually have a negative y, and a 6x. So I would get 6x subtract y equals 11. Nothing cancels out, so that does me absolutely no good. So what I need to do is I need to alter one of the equations. I need to multiply one of the equations by some number so that I create an equivalent equation, an equivalent system of equations. But now two of the variables will cancel out. Either the y's will both cancel out or the x's will cancel out. I actually have a couple of options. If you'll notice, I have an x here and an x here. I could multiply something times 5, maybe. It would actually have to be negative 5 because this is a positive x and a positive 5x, and I need to flip the sign in order to be able to cancel those out. Could multiply by negative 5 up top, and then the x's would cancel out. That's a higher number than I would prefer to use, not that it makes it too much more difficult. But I also noticed that I have opposite signs. I told you to look for this at the beginning. If you have opposite signs, especially on the quiz, look for this. That's where I would start. And I notice immediately, well, I have this y, and then I have 2y. How can I get from basically there's a 1 in front of that y. How do I get from 1y to 2y? I just multiply by 2. And then my signs, I don't even need to do anything with a negative sign because I've already got a positive sign up here and a negative sign up here. So those are just going to automatically cancel out for me. So let's get rid of all of that I did. So I'm going to multiply this top equation. First, I'm going to move the top equation down a bit so we can see it a little bit easier. So I'm going to multiply the top equation times 2, and we'll do it in blue. So I'm going to say x times 2, y times 2, and then 3 times 2. I have to multiply every single term when I'm doing this. I can't just multiply it by the y, or even just by the y and the 3. So my new equation is going to be 2x plus 2y equals 6. Now I'm just going to bring the other equation down from the top. We didn't do anything with that. So that's just 5x subtract 2y equals 8. Go ahead and extend the page a little bit. So now I notice that I can add these vertically and have something cancel out. The y's will now cancel out. And that was really our whole purpose, was to get the y's to cancel out. I get 7x. I get 0 there. So we can put plus or minus 0. It doesn't really matter. And I get that equals 8 plus 6 is 14. So now, whenever you do math like this, you're always going to just skip straight to division. Whenever you do a problem like this, I mean. So my last step is going to be divide by 7, and I get, that divides out to 1. I'm left with x, and then that divides out to 2, 14 divided by 7. I get x equals 2. I am not done. You have two variables in the original equation, right? X and y. I need to solve that top equation. X plus y equals 3. So if x plus y is 3, and I know x is 2 now, so 2 plus y equals 3, well, clearly y must equal 1. You would subtract 2 from both sides to cancel out 1 off, and then you would say 3 subtract 2 would equal 1, get the y equal 1. So that's a quick video. I think that covers pretty much everything that's going to be in there, though. There will be more problems, though, than what I did in this video, but nothing different than what I did.